we're starting a new topic today, indices. So these are some of the modules that you're going to come across first. I just want to give you a quick rundown of the topic as a whole so that you can kind of see where it's going. Now with indices, we're looking at putting numbers into the form of something to the power of something else. So before we even get onto it, you need to have mastered modules on factors. So there's a bunch of them. There's one that's actually called factors, where we've got to find factors of numbers up to 100. Now we've talked about the way factors are two numbers that you can multiply together to make a bigger number. So for example, the factors of 6 would be 1 and 6 because 1 times 6 is 6, or 2 and 3 because 2 times 3 is 6. So factors come in pairs, don't they? Now there's lots of modules on factors, so if you're up to this sort of level, you'll need to complete modules on factor trees and large factor trees. Then it will move you on to a module called indices, where we're really just introduced to that idea that if we're multiplying something by itself, for example 5 times 5, we can write it like this. Now you'll notice that what we're really doing here is we're writing out the 5, and so that there's 2 of them, and we're placing a multiplication sign in between. So it's really just a quick way of showing when we're multiplying a number by itself multiple times. And this number up here shows us how many of them there are. So for example, 2 cubed, and we say this is cubed here when it's to the power of 3. 2 to the power of 3, or 2 cubed, is 2 times 2 times 2. Now, they're not asking you here to actually work out what that comes to. I can see that 2 times 2 is 4, and if I multiply that by 2 again, I'm going to get 8, aren't I? But in this module, they're getting you just to transfer between writing it in index form and writing it in what we call expanded form, which is writing out the number with the multiplication signs in between. You don't have to actually work out what it equals. You just need to be familiar with each of these being able to be written so that they mean the same thing, but they just look different. After that, you're introduced to multiple indices, where you might get 2 different index expressions. Now this part here is just 3 times 3, and this part here is the 4 times 4 times 4. So if we multiply them both together, it just means we keep on multiplying, and we end up with a whole lot of numbers multiplied together. Again, they're not asking you what this equals, they're just asking you to put it into what we call expanded form. Now in the next one they say, all right, let's evaluate the indices now. Now this part of the word here, value, tells you we're trying to find the value. We want the answer. So we know that 3 cubed, once we've done these modules, is 3 times 3 times 3. This module says, well, what is that? Okay, 3 3s are 9, and if I multiply 9 by 3, I get 27. So that's reasonably logical. Most of them are numbers that are between 1 and 10, so there's no really difficult multiplications to do. Then when you get to evaluating large indices, there are much bigger ones. So for example, something like 11 cubed, you need to reason that it's 11 times 11 times 11. Now this is harder to do in your head. You might be able to do the first part in your head and say, hey, that's 121. But when it comes to doing 121 times 11, you might need to use one of these sorts of strategies, or another method that you might have for doing 121 times 11 and actually figuring out what the answer is. So again, we're finding the value, or we are evaluating them. After that, you'll move along to index expressions. Now, this one seems really similar to multiple indices, and it's like you get a deja vu because you think, haven't I done this before? The only real difference is they get you looking at the expanded form and rewriting it in index form instead of the other way around. So that seems quite straightforward once you've done these other modules. And then you get moved on to this one, laws in the language of algebra, and you're going to wonder what on earth that has to do with indices. But you need to understand the distributive law before you can move on to the next indices modules. Now the distributive law just says, let's just take a step back. Remember in primary school when your teacher taught you to always do the brackets first? Well, in this module, they throw that on its head and say, let's not do the brackets first. Let's look at another way that we can break things up. So, for example, here I've got the 3 just written outside, 10 plus 2. Now, since you've done algebra, you've learnt that if there is no sign there and something is just smushed together with something else, there's an invisible little times sign in there, isn't there? So really we want 3 lots of 12. Well, you know the answer straight away, probably, that 3 12s is 36. And if you use the strategy of doing inside the brackets first and getting 10 plus 2 is 12, 3 12s is how you do this. But there's another way. you can say, hold on a minute, what if we weren't going to add these together and get the 12? Well, if we've got three lots of a number, and the number has two parts, it makes sense that we've got 3 of the 10 part and we've got 3 of the 2 part. And that gives us 3 10s, which we can see is 30, and 3 2s, which we can see is 6, and we can add them together then and get our 36. Now, lots of people doing this module get confused because they don't really see the value of it. They go, yeah, that's fine and everything, but I'd just rather add up the 10 and the 2 and get 12. That's way easier. The reason they teach you is because then it leads you to be able to work with algebra and say, well, what if this wasn't 10? What if it was, I don't know, a letter like B? Okay, now I can't do B plus 2 because I don't know how big B is. It's a variable. But this new method tells us that we could do 3 lots of the B, and that would give us 3B. And then we could add that to 3 2s, which is 6. So by learning this distributive law and how to not do the brackets first, you're setting yourself up to be able to do more algebra work later.